Greetings everyone, Fru here. Welcome to the channel. Welcome to the Demo Hub. In today's video, we're going to do a presentation about language models. And this presentation has been much demanded by the community. It's going to be a primer for beginners to understand language models and all the rage seeing in the industry as tech professionals and the competition and the innovation that's happening in this space. Now, my name is Fru. I am the founder and the host of Demo Hub. You can find more about Demo Hub on the website Demohub.dev, a little bit about me, as well as if you want to be a guest on the Demo channel to demo your product, technology-oriented product, there is a page in there for you to submit and to book your session. So if there's any product or any tool or idea or thought leadership you want to come on and demo and share, go ahead, use that link and submit to book a session. Now, going to our presentation, language models for beginners. Why is this a relevant topic to talk about or to make a presentation about? At this point, if you work in technology or business or anything in between, at some point you would have come across someone talking about ChatGPT. ChatGPT is the generative pre-trained model from OpenAI, and it took the internet by storm. It took the technology world by storm. Something has gone mainstream when even you go to the coffee shop and you get your coffee in the morning and the barista is talking about ChatGPT. That's how mainstream ChatGPT has gone. Just even going to Google News, the top story as of recording this today is about ChatGPT and the competition they are seeing from Google trying to come up with its own language model. So very fascinating. Drilling further, almost every paper out there is talking about ChatGPT or generalized pre-trained models or language models as a whole. And what this means is that as technology professionals, we cannot afford to be oblivious to what's going on. We cannot afford to not understand what is actually happening and the impact that has for us, for our businesses, for our companies, our organizations, and just society as a whole. Now, if you go on Google, there is a lot of articles. If you go on YouTube, there's a lot of videos about ChatGPT and ChatGPT demos, and everyone is talking about language models. But no one is really stepping to explain a little bit, just one step further, what this means or why this is such an important thing or even how it works. And that's what I'm really hoping to unpack in this video. We're gonna go deep and unpack this in this video. Here on the screen, you can see again another article. This one is coming from the NVIDIA blog. It talks about a survey of the top executives and their priorities for AI for 2023. And guess what? Large language models is on the top of that list for use cases for AI. So AI has gone mainstream. I think we all can agree that. And language model is trailblazing that as far as the use cases and the adoption we're going to see from AI is concerned. So links to all of this will be in the description below if you want to go ahead and read a lot of these articles. Now, even going to Google Trends just to pay attention, and this is something I do quite often, keeping a radar on the technology landscape and what's happening. You can see language models is picking up steam as we got into 2023. You can see that explosion, and I can guarantee you that this is just gonna go even more. This is gonna go off the roof as more and more people become aware of language models and what that could mean for them. It's gonna disrupt almost every industry you can imagine, from advertisement, writing, publishing and writing books, creating content on social media, or just how businesses interact. Language is something we all use. There's no communication without language. You have to speak, you have to communicate with somebody using a form of language. And if we see a disruption in that space where machines can generate language for us almost as effective as humans can communicate, then this is really something that we all have to pay attention. Now, why is this a topic that you talk about, and why am I the right person, or at least capable of having an opinion about this. Now, I'm not an expert at models, I'm not a linguist, but I am stratospherically interested in this concept. To give you a little bit of a background, a few decades back, it's a couple of decades now ago, back in undergraduate, I did mathematics, I did computer science, but there is always that part of me that has a very unique interest to languages and how they work from a formal perspective. On the screen, I literally hesitated to put this up because I don't know where this will go, but it's out there. It's part of my body of work. It's important so you can understand why Fru is the one talking about this. A few decades ago, I did this project looking to understand language. I'm not going to go into the details of what exactly I was doing, but it was essentially using the computer to do some translation for me for numbers. That was particularly interesting to me. Now, when I look back, my knowledge was very limited, rudimentary, very elementary at the time. Being an undergraduate, trying to understand language to what the industry is doing today or what was happening at the time. But this just shows you how interested I was. So I had this translator. You can select your language and it can predict or translate numbers for you. And I'm not going to go into how I made it work and how I did it, but essentially it had some ability to train, so you can synthesize. I call it the synthesizing. You have examples, give it examples and train your language model. I didn't call it the language model at this time, but you train something using a vocabulary. Once you've trained it, you can come in and essentially you can put in literal or a number and pick a language. I had over 20 something languages at the time, and it would translate this integer to you, from you to the language. Here's Mandarin. You can imagine Mandarin is a little bit of a complex language. I had it for English, French, all the languages you can imagine out there at the time. Now, how sophisticated was this? Again, I'm not going to go into the details of it, but I have this in this space, which is why making this and showcasing this is really to amplify the point that models is something that, even if I'm not an expert, I'm not a linguist, I'm not a practicing linguist, but I'm just somebody that has supreme interest in this and this innovation we're seeing in this space. So my goal is to unpack this for somebody who is looking at language models and thinking, oh, this is so fascinating, but you don't really understand. It's still a black box to a lot of people. You don't understand what's happening. My goal at the end of this video is that you will have a rudimentary understanding of what is happening, at least more so than the average person who is just going in and typing things into ChatGPT and getting results. So to jump in, let's play a game here. Let's use a couple of examples of what language models are and what essentially they do, because that's ultimately the question people are trying to ask and answer. Beyond just using it is really understanding what is this and how does it work. My goal is that we're gonna unpack that shortly, but let's play a game. And I'm sure we've seen a lot of these games on game shows where you have a couple of words or a couple of prompts, and the goal for us is to somehow fill in the blank. Oh, there you go, I gave it away. All right, so if we come in here, we see this, there is fill in the what is it here? Blank. I think I gave that away, unfortunately. All right, so we can predict what the word here would be based on what the sentence would be. Right, there are just a few words that we can make it work here. This is not going to be a Z, it's not going to be a Y, there's going to be a very few set of words that can go in here, right? And based on our knowledge and our understanding of language, we can predict what that word would. Let's try another example here. So looking at this on the screen, can we somehow use our knowledge of language, looking at this prompt that has been given to us, fill in the blanks of what this sentence should be? Okay, so let's start from the beginning. Number one, if we say, okay, that's an L, I'm sure by now it can start prompting. If this is an L, there are very few words that are, or very few letters that would have to go into this location. And so if we tap into the language model in our head and almost think like computers, now you can go in and say, okay, this is gonna have to be, it's not gonna be a P, it's not gonna be a Z, it has to be something different, right? Usually it would be a V. So leave, and then here we can start again predicting, well, what is this gonna be? Very few letters will have to go into this location. And if we take a look at that, leave it, and what would go here to What could go here? Beaver, right? Leave it to Beaver. It's a little bit of a next one, but I think you get the point. That based on our understanding of language and certain rules and grammar and how language works and the syntax that has to go with it, and pay attention to those words I'm using: syntax, rules, grammar, we can effectively complete sentences even if we don't have complete information. The next example here, if we again look at this is just one word. Again, let's tap into our knowledge of language, which consists of syntax, grammars, rules, and all the rules that apply to, in this case, we're talking about English language here, but be rest assured, every language in theory would have certain rules that they follow. Okay, so here, Colo, M, and then what will have to come next is probably going to be a B. So Colombo, right? So again, we're tapping into language, the syntax, the rules, and the grammar to effectively fill out something like this. Now, what we've seen here is what we all do instinctively without even thinking. We do this all day long. If you speak, this is what you're doing all day long by reading, writing, learning. Now, what the linguists have done, again, I'm not practicing linguist, I'm not formally trained in that space, just very enthusiastic about it, is they've taken language and really unpack that from a formal perspective into the different building blocks of it. So if you heard me in the beginning talking about the syntax, the grammar, and the rules, that's essentially what language is all about. So if you think of the English language, there is a finite amount of words that are in English. It's a large amount. Not everybody knows all the words out there, but there is a finite amount. In theory, there's a finite amount of words. And there is a finite amount of rules in which those words can be interconnected. There is a finite syntax in which you can take a noun, a verb, an adjective, and all the different building blocks of the language and formally string up every word in theory that there is out there. If we have a noun, we know after a noun, a verb has to come through. After a verb, an adjective. If you have an adjective, you have to have a noun afterwards because the adjective describes a noun. Something to that effect. There is a formal way in which linguists look at language to understand it, and what these language models are doing are simply just formalizing that and making the computer do it for us, because computers are amazing at doing it for us. The example I'll give here before we jump off on this tangent is, think about how computers can calculate very well. Take a computer, say 4 plus 4, boom, it gives you 8. Well, how does it know that 4 plus 4 equals 8? It's because we've given it the rules to say, if you have this number and this number, you follow this rule to add it and use base 10, and it's going to give you this number. So computers have been doing addition or calculation for forever using the rules of mathematics. And we've done that for a long time from the abacus, and computers have figured out how to do it. Now, that level of knowledge is coming to linguistics, language. And the different languages out there are just getting really good at doing the calculation of language, for if you want to put it that way. This diagram, again, links in the description, shows us the levels of linguistics. For me, I simplify it into 3 main things: the syntax, vocabulary, and grammar, which is the rules. And semantics, if you take your vocabulary, which is your set of words, you apply grammar to it, which is the rules in which those words can be strung together, you can in theory come up with any language. And then you can pronounce things differently, you can enunciate things differently. Words have meanings, or their meanings might change based on their positioning in a particular sentence, and computers have to understand all of this. But this is what goes into understanding language from a formal perspective. Now, why am I emphasizing a formal perspective? The reason is because language could be used formally and informally in the way we speak, and that difference becomes very important for computers. So a formal language would be full sentences, what we have here on the left. The grammar is correct. There are no contradictions, very few idioms. We're not using words that don't have abbreviations, right? And so there are certain rules that you follow when you're talking about formal language. It's like if you're writing a formal letter to your employer, there's a way in which you write that compared to if you're just talking with your friend out in the bar or just hanging out at home and having fun. The way you speak, the language that you use fundamentally changes, and it's important to understand those distinctions. Now, when we talk about language models in the past in academia and what work was done previously was around formal languages. But in the world, we don't only use formal languages. If I go to Google, Google doesn't know if I'm typing a formal language or if I'm not typing a formal. So if language models are going to get the adoption that we're seeing now, they have to address both of this. That's where the chat GPTs of the world and the words that Google is trying to release have caught up, and they can adapt to even informal languages more so than they used to be able to do. So understanding the differences between formal languages and informal languages is key. But the beauty of it now is most language models, they can adapt to both. You can go into Google and type idioms or type a joke, and you'll be amazed by Google. I mean, the new bat they're gonna release, and then ChatGPT as well. If you type any of that into those platforms, you'll be amazed at how responsive they can understand even jokes or things that you would use in informal discussion, and those language models are being able to understand. All right, now the next piece here is, if you look at linguistics, anyone who studied linguistics or really wants to go deep into this, sooner or later you're gonna come across this name called Chomsky, Noam Chomsky. He's political active, but in the academic space, in formal languages or in linguistics, he's written a lot of books. If you study linguistics in any form, you're gonna run across Noam Chomsky one way or another. He has a strong perspective on how grammar works, regular grammar, context-free grammar, context-sensitive grammar, unrestricted grammar. This plays into what we talked about in terms of formal languages. If I'm talking to a friend, I could say, I'm red today. What does that mean? Maybe in the regular grammar, it means nothing because red doesn't describe a feeling. But maybe in the context of your discussion with your friend, red describes a feeling of being happy. So grammar is not restricted in that sense, as opposed to formal and regular grammar where you have to string those rules. There are certain rules, again, that English allows you to follow. And if you extend that to most languages out there, you can come out with grammatically and syntactically correct words or sentences. So very big in this space, the Chomsky hierarchy, he talks about this. And back or early on in language models, before the Renaissance and the really big adoption, and I'm seeing now, this is how linguists or translators were working with. A lot of those translators were using rules. Essentially, if you had to make a translator, you have to go in, understand all these rules, feed that into your language model or translator. If you think about the very early Google Translate, it would be someone understanding English and all of these rules and how things all should come together. You feed that into the translator, and Google at the time could take it and do translation for you. Another example you will come across if you go down this path is, take a sentence, it's broken down into the noun phrase, the verb phrase. Within that, you have the article and the noun. Article, noun, and let's just read through this. So the cat sat, the mat. So for example, you have the article and the noun. According to English, the article has to come before the noun. You cannot have a situation where you have the noun before an article. It's not accepted in English grammar, in English rules. So if we can say cat on sat, it just would not make sense. At that point, you're breaking the rules of English, you're breaking the grammar of English. And so by understanding the formal structure in which sentences are strung together using the different building blocks of articles, nouns, prepositions, verbs, and all of that, you can come up with English that is grammatically, syntactically, and it's semantically correct. And this is really the study of linguistics and the language models out there. This is what they look at. Now let's look at another example here again, how this all builds up. If you read into Noam Chomsky, this is what they talk about. Here you have colorless green ideas sleep furiously. Again, if you do the breakdown, you will understand that this is a grammatically correct sentence because grammatically it follows all the rules. You have the adjectives, the nouns, all following the verbs, and the way English prescribes it have all been implemented here. Synthetically, it's also correct. If you look semantically, it is also correct according to the English rules. Now, the question is, can computers do this? If we formalize all of this machinery behind here, can computers somehow figure that and derive that for us? Take, for example, we might say the students open their, well, fill in the blanks like we did before in the games. So there are a few set of words according to English that would have to go in here. It could be books, it could be laptops, it could be exams, it could be mines. So now the computer or the language model, their job is to predict what goes in here. Just like when we started before and I asked us to play the game of being language models and you were predicting and filling in the blanks of those words. This is what language models do. You give it a prompt. If you go into ChatGPT, you give it some prompt. It's going to spit out a sentence based on what it understands and interprets your prompt to be. Now, if I had more context behind, and this is where we talk about context-free grammar or context-sensitive grammar, because the context behind here could influence what my prediction would be. For example, if we were talking about the student arrived in the classroom and the teacher told them how long they had to do their writing. If that was the context behind this particular prompt, then we can start eliminating a few words here. It wouldn't be mine. We might start thinking it's a timed discussion. Then maybe it's more an exam or reading a book. Again, by using context and understanding the prompt, the job of a language model is to predict what the next word would be. And if we can predict what the next word would be, then think about predicting what the next sentence would be or what the next paragraph would be. That's what ChatGPT and those other models are doing. They're not just predicting the next word for us. They have gotten so good that they can actually just, with a very little hint or a very little prompt, they can predict to you what the next word will be. People talk about artificial intelligence and talk about how this is sentient. My opinion on that is a little bit different. There's really no sentience happening in this. Saying this is sentient is probably from somebody who doesn't really understand what is happening behind the scenes. This is mostly prediction with heavy statistics behind it, and it's very novel. I give it that, but we're getting ahead of ourselves here if we start calling this sentient. Going back to the examples, let's try another example again of prediction, because we can do this. We've been doing this for a long time. Being able to predict doesn't mean we're thinking. It just means that we have enough context or we have enough understanding of the rules and the language that we can give you what the next sentence will be or what the next word will be. Can you please come? What word will be predicted? Now, you can say, can you please come green? It doesn't make sense. Or you can say, can you please come running? Sure, maybe that makes sense. It's a little bit more probable than can you please come green. So based on the rules of and the grammar of English, what should be predicted? Giving the idea of giving a prompt and being able to get an output out of it is what language models do. To summarize this, in the past, the way they did this was by using rules. Take a language, you manually encode all those rules of how a verb and a noun and an adjective are all strung together. Based on that rule, you can create grammatically and syntactically correct statements. The language model can use that to do its prediction by just tapping into the library of rules and the vocabulary. Now, the switch that we've seen with these large language models today and the deep learning neural network with retention and all of that is switching from the rule-based way of doing translation and working with language to a more statistical method base where you don't have to encode all the rules. Think about all the rules in grammar, the nuance, and all the different ways that people use language in subtle ways that a word doesn't always mean what it means. For the model to somehow decode and capture all of those nuances so it can effectively predict for us, that's what these language models have done. They don't do it by looking at rules. You train the model by giving it a big library of English text and somehow fish out all those rules. Again, you're not manually training, it's deriving the rules itself, and then you can use that for predicting the next word. And it's pretty cool. It's pretty cool what has been accomplished, but it's not magic. It's inevitable that if we have the computational power we have today, then it makes sense that naturally we are where we are, because the computers can now use all the computation they have to give us these results that we're seeing. If you think about, again, ChatGPT coming from GPT-3, trained on what? 175 billion parameters. So billion data points that has been trained on for it to understand the rules of the language English. That's why this is so amazing. Here on the screen is just the ecosystem of language models that are out there. Again, if you're looking into this space, sooner or later you're going to run into this. There are really a couple of families. The BERT, which is the bidirectional encoder representations from transformer, is really pioneered by Google. And out of BERT, there are many different families out of it. You have the Roberta, the SpanBERT, Elmo, Albert. There is a bunch of different derivations from the BERT family. On the opposite side, call it opposite side because Google is pushing the BERT away, the bidirectional encoder representations from transformers. That's what BERT stands for. And then the GPT, which is on the OpenAI side, the generalized pre-trained models or the generalized pre-trained transformers, is on the GPT, where you had the GPT-1, GPT-2, now there's GPT-3. Hopefully GPT-4 is going to come out. GPT-3 is what is powering OpenAI. If you go into OpenAI and you're using the ChatGPT that everyone is loving today, it's powered again by this language model from the OpenAI ChatGPT. But behind the scenes that we've seen here, these models, all they do, if we were to simplify this for the everyday person, is give it a word and it's gonna predict to you the next word based on its understanding of the rules, the syntax, and the grammar of English. There is no magic to it. It's so good at doing it that it not only predicts the next word for you, it can predict the next paragraph for you. That is cool. That level of retention, that level of understanding of the rules of English is what makes it so amazing. But to jump from there and say, oh, this is a system, that's where people are losing me at this point in terms of their understanding of what's going on. That's why I wanted to do this video, to really demystify this for folks. When your boss is talking to you about the language models, or someone starts talking about ChatGPT and how the machines are going to take over, doubt it. Again, the example I'll give is we've been using calculators for a very long time, and you can punch in any number into a calculator and it's going to do amazing math for you. Does that mean the field of accounting has gone away? No. Does that mean we don't have accountants anymore, or we don't still have to calculate? We do, but the calculators just help us be more efficient. Instead of me trying to do very complex additions off my head, I let the calculator do it, and I just take the results and I build a house, or take the results and I file my taxes, or I take the results and plan my trip to a destination. But the computer is doing the math. To me, that's how language models will become effective to us. People talk about, well, the language models are going to come and take your job, or the language models are going to get rid of programmers. None of us can predict the future, but if we rely on the past and use the past as any indication of what the future will be, that's we're stretching it at that point. Models will help. They will help people be better programmers. They will help people be better doctors. They will help people be better journalists. They will help people be better students. But does that mean journalists are going to all of a sudden be out of a job? Again, I think those are people who are just being sensational. They don't understand what's going on. You just want to hype it up and make everybody worried. There's no need to be worried about language models. This has been a long time coming, and it's just going to help us be more effective. If you're going to be a journalist, now you can write even more interesting articles and have more content to put out there, because the language model is going to help you. Is it going to replace you? Nope. My calculator doesn't replace me. It helps me do better calculation, but I still need to know what I'm trying to calculate for it to be useful to me. If you don't know what you're trying to calculate, you can have the best calculator on earth and it's not going to help you. Same thing with the language models. If you have no idea, if you have no core thesis or no interesting thing you're trying to put out there in the world, you can just spit out a bunch of sentences that make sense grammatically, syntactically, but it still means nothing to anybody if those things are not applied to effective problem solving. That's really what people should focus on when we think about these language models, as opposed to being sensational about what it is all about. As I promised, I'll leave this presentation with a couple of links here. If you want to go deeper, it's been a long time, to be honest, that I have gone back and really paid attention to this field, not just on the application of what is being built, but on the theoretical side. So I might be out of my skis here at this point in terms of the new advances. But when I was introduced to this field, like I said, Noam Chomsky was somebody that I read very early on, and I knew he was a pillar in this space with his Syntactic Structures, a great book. He has a book on mind and how we think and how language really plays into us. I would recommend, because language is such a pivotal part of our society, and if this is something that interests you, formal languages or linguistics or natural language processing, read some of this literature. It would really help demystify what we're seeing here today. There is another book too by Peter Lin's Formal Language. And fortunately, there is a PDF here too as well. I'll leave a link to all of this in the description below. What we've talked about in this very brief primer, if you want to go into the formal description of all of that, you will see these books really capturing that. Now, there is a lot of math behind it. So if math is not your cup of tea, you can skip it. But at the very least, now you understand that what we're seeing again with ChatGPT and the announcement coming out here from Google and Bard or Bard, I really don't know how they pronounce this yet, on their own language model, is just the natural product of all of this formalization or this theoretical foundation really coming into its own. Now, the last comment I'll make here is that, again, language models are nothing new. We've had them for a while. The way the foundations, the theoretical foundations have changed from rule-based and grammar-based, very intensive, where you have to manually feed in all these grammars and syntax and structures, to more statistical based, where deep neural networks and all of that are able to fish out those statistics and make those long-form predictions, have retention, have all really come into play. But what ChatGPT did, which is very disruptive, is not just the language model, because ChatGPT is powered by GPT-3, and GPT-3 has been around for a while. One of the big revolutions here, and this is something that people should really pay attention to, is the interface, is how we interact with that language model. This idea of having a chat way of interacting with the language model is one of the disruptions that ChatGPT has unleashed to the industry. And this is what everybody really should be paying attention to. That's why Google had the Lambda language model. This is nothing new. They've been sitting on this for a very long time. Well, why didn't they use it, or why didn't they put it in a chat form? That's really up for you to ask Google. The interface to me is the biggest disruption and the biggest eye-opener, as opposed to the language model. A chat interface will be what people appreciate more so than anything else. That's really the big innovation here, and something to pay attention to. And like I said in my previous videos, if I'm a product developer, if I am a founder or some executive, I'll be thinking about not just how my company or my organization is building or leveraging these language models to solve everyday problems, from customer service, from responding to issues and creating literature from my organization, but how are we enabling that in a chat fashion? Again, because people seem to love chat. If you just have a static blog or a static book or static that you send out, maybe that's not gonna work. Maybe you need to start thinking about, how do I train this, localize the vocabulary to my industry or to my language, and then open that up as a way of chatting to the model and making that work as effectively as ChatGPT is doing. That's the biggest opportunity that companies can go in and tap to get significant amount of value from all of this. Lots of resources, lots of links. Hopefully this presentation was helpful. It gives you a primer, unpacked or demystified this for us. This could be intimidating for folks that are just seeing it. There's a lot of misconception out there. Journalists are jumping on this who have no idea what's happening behind the scenes. It's important for all of us to, at least in a level field, as far as our understanding of these language models are concerned. I've left some links here, so go out, research. This is such a fascinating field. This has been through. Do like and share and subscribe here on Demohub. If you have any questions, let me know in the comment section below. I'll see what I can do. Thanks, and I'll see you in our next demo.